So what is the definition of a sine and cosine functions of any size angle? Let UV be a point r units from the origin on the terminal side of a rotating ray. If theta is the angle in standard position to the ray, then sine theta is v over r and cosine theta is u over r. Now, to begin with, because that definition is a little bit confusing if we are not familiar with the terms. So first, let UV be a point r units from the origin. So let's say this is our point UV. And of course, we have to label this point as UV. Okay, where our U is the x coordinate and our V is the y coordinate. Where is our origin? Our origin is here. Okay, next, this is r units away, meaning that this is called r. Okay, next, we are on the terminal side. Yes, this is our terminal side. So we have our angle from the positive horizontal axis going through here. This is our angle theta. Okay, and this is our rotating ray. This rotates. This one is our rotating ray. Why is it called rotating ray? Because it rotates. I mean, it could change an angle from theta going to another angle. It could increase its angular displacement from this x to here. So that's why it's called rotating ray. Next, if theta is the angle in standard position to the ray, then sine theta is equal to v over r. So our v here, if this is our u, then we could also take this as our u. Am I correct? This is actually our u, right? And this is our v. Am I correct? So, meaning, this terminal side of theta is this one. Okay, so this is the terminal side. Or terminal position. So what are we going to do here? Let us define some variables. Our r here, so as you would notice, we are actually creating a right triangle here, right? So we have a right triangle here, starting with this. Look, we formed a right triangle with r as our hypotenuse. So r is the hypotenuse. What is the definition of a hypotenuse? The hypotenuse is the longest side of a right triangle. And we have a right triangle in here, which is defined by this point, by this angle here. So maybe I could try to fill this. So this is our right angle. Okay, the filled one is our right angle. So r is our hypotenuse, or the longest line of the triangle. And then what else? Our v is our opposite side. Opposite because it is opposite the angle. So it is the side opposite to your angle. Am I correct? This is facing this. Therefore, this is opposite to v. And v is the opposite of the angle theta. Okay, what else? We have u. So u is actually the adjacent side because it contains the theta at one of its. The theta is contained in this line. The theta began from this line, which is also called the initial position. So the adjacent side, U, contains the theta. Okay, so now we are going to define our sine and cosine functions. So our sine here, the sine of our angle theta, sine theta, or just simplify it to sine theta, is equal to the opposite V over the radius, or I'm sorry, the hypotenuse R. Okay, and for cosine theta is equal to cosine theta, which is equal to the adjacent over R. Okay, so this is the definition of the sine function and the cosine function of any size angle. Any size, because your angle could be big or small depending on the given. So these are the definition. This contains the definition for the sine theta and the cosine theta. So let us verify the positions of the theta and also the values of your cosine and sine theta. So presented here is a circle. This is actually a unit circle. This is a unit circle. And this unit circle is where the sine and cosine functions are taken. So we have 4 quadrants here. Remember, in your Cartesian coordinate system, you have 4 quadrants. This is quadrant 1. We could abbreviate this as quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. And in here, the essence of this quadrants is to determine the values of your sine and cosine theta. Okay? So if our angle is theta. So given that our angle is theta, theta is the angle, any angle. Then in quadrant 1, and take note of this, this is very important, as your x is positive and your y is negative, then your u is also positive and your v is also positive. So in essence, we have a positive part here. Okay? And as a technique for easy understanding, for the cosine value of the theta, that would be accountable for the first sine. So this will be for your cosine of theta. And this one would be your sine of theta. And this is true for all of the quadrants. So in here you have positive cosine, positive sine. In here we have negative cosine, positive sine. In here we both have negative sine and cosine. And in quadrant 4, we have a positive cosine and negative sine. So this is how to memorize or how to familiarize with yourself with the cosine of theta and sine theta values. So if you are given in quadrant 1 and you are asked to compute for your cosine theta and sine theta, sometimes you would make a mistake or we will be confused whether what we are going to take is the positive or the negative of the value. So just bear in mind these 4 quadrants and you will not get lost. Okay? So these are the, what do you call this? These are the values for cosine and sine for any of the quadrants. So remember where your angle is. It could be in quadrant 1. Your theta could be here, or it could be here, or it could be on the 3rd, or it could be on the 4th, depending on what the requirement in the problem, in a certain problem is. Okay, so as individualized, if we are in quadrant 1, then this would be the sketch of our theta. And our theta is this angle, okay? And our cosine here is positive, and our sine is also positive because it's going up. And in here, your theta is going down. So your cosine here goes down, so it's negative. Your cosine, but your sine here is positive. And here, both are negative because the value for your theta is going down and it's negative. It's on the third quadrant. Okay, but in here, it's going up. Your theta is going up, meaning the rotation goes up. So your cosine is positive and your sine is negative. Now let's go to the periodicity of sine and cosine. Since both sine and cosine functions are periodic, meaning at some point they repeat each curve or each pattern that they do, such as in this case, they are repeating, right? They are periodic because they repeat patterns. Okay? So what is about periodicity? So let us take this graph as an example. Let's erase the highlights that we did and then put it here. Okay. So look at the Cartesian here on this coordinate system. So we have, I'm sorry, that's not the one I'm supposed to write. Okay. So look here, and well, the center should always be in the origin. So this is a mistake. Okay, that would be for quadrant 1, and this would be for quadrant, okay. This is for quadrant 2. We need something for quadrant 4 and quadrant 3. This is for quadrant 4, and this would be for quadrant 3. So now they coincide at the origin. Okay, now let's take a look. So this is our theta here, right? This is our theta. And our theta for this is this, okay? And for the third quadrant, it would be like that. And for the fourth quadrant, it would be like that. Okay. So, as you can see, this is point UV. And the Cartesian, the coordinate system we use is UV. So these points here are all UV. So this is UV, 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 UV. So we have, at this point, the point is UV, right? This is negative U, V. This is negative U, negative V. And this is U, and then negative V. So V here is positive and increasing in this case, okay? So V is positive and increasing. Yes, it's positive. If we are going to draw these lines, this is our V. This is our V. This would be our V. And this would be our V. Okay. How about our X? I mean our U. This would be our U. This would be our U. So let us analyze. Our V here, is positive and increasing, so it's going up. And our U here is also positive, okay, greater than 0, and going to the right. And in here, our U is positive, V, I'm sorry. Our V here is positive, and it's also increasing, so it's going up. But our U is negative, and it's going to the left. Here, our V is negative, it's going down, and our U is negative also, it's going to the left. So look at the directions. And in here, we have V is less than 0, and it's going down. Now our U is greater than 0, it's going to the right. Okay, so we could see that for Y, for our V, in terms of the direction, in here, the V is increasing. Also here, it's increasing. In here, it's decreasing. And here, it's decreasing. So both in the third and fourth quadrants, your V... Okay, I'm sorry. I think I have some mistake here. This is the V. Okay. This would be... We're actually looking for the angle here. So we don't need our U anyway. So our V here is greater than 0, and it is decreasing. You can see that your theta here is in here it is increasing, and it's positive. In here it's also positive, but it's decreasing because it's going down. Okay, so this is going down, so it's decreasing here. And on this quadrant also, you could see that, it is decreasing. Your V is decreasing. It goes down. And also, it is negative, so decreasing. But in here, you could see that, your V goes up. It goes up, okay? And this is also increasing. To determine whether it's increasing or decreasing, you have to look for your theta. Your theta here is going up, so it is increasing, I'm sorry. And in here, it's going up also, going down, going down, going up. So these are the values of your V. If we are going to plot the sine, this is the cosine. This is for cosine, okay? This is for cosine of theta. So looking at your cosine theta, these are the critical points to be evaluated. So looking here, at this point it is increasing, right? So it is increasing here. And here it is decreasing up to this point, okay? So in here it is still decreasing. But in here it is going up, so it is increasing. Okay, and also here, so it is increasing here. And going here, it is decreasing. And here, finally, is increasing. So this is sinusoidal. Okay, so this is how we trace the patterns for our cosine theta. This is periodicity. So as you can see the periods from here going to this and it increasing again. And then like that, and then increasing again. So we could see a pattern here, okay, of periodicity. So for cosine theta, then we could tell that why cosine theta is actually increasing. So this is for this lesson, periodicity of sine and cosine. For the next lecture, we're going to have examples to be able to determine the important elements in this lesson. Thank you for watching.